Great. Well, thank you very much for the opportunity. My name is Stefan Burrell. I'm an associate professor in the Department of Epidemiology at the Johns Hopkins School of Public Health. I also am a population health physician and a general practitioner, and I work within homeless settings and provide primary care to folks experiencing homelessness, and have been doing that throughout COVID in person. So there's a couple of questions that have come in today that we're gonna talk through. So one of them is this real question about like, what are the main transmission pathways? So like, what are the real risks for both sort of the acquisition and transmission of COVID? And I think, you know, this has been something that has clearly been a hot topic really throughout the life of this pandemic. I will say that I tend to use PASS as prologue a fair bit. You know, this is a single-stranded lipid enveloped RNA virus that is not dissimilar in size from influenza. And so while there's been a lot of topic and a lot of talk about, you know, the differential case mortality rates and infection mortality rates, which clearly this is a much more severe infection than influenza, but I still think that there's a lot to learn about transmission from what we know about influenza, given the fact that, you know, one is a positive and one is a negative single-stranded, you know, lipid envelope virus. And so in that, you know, this is a virus that has a few different pathways for transmission. Contact transmission, droplet. And while I'll say that, you know, droplet is clearly, as we've talked a fair bit about throughout the life of this pandemic, again, is like a continuum. Because there's, you know, while we officially define droplets according to a specific size, the reality is that like our body and biology doesn't set droplets along those size. And droplets can be, you know, tiny and they can be very large. And obviously there's an inverse relationship between how big they are and how gravity affects them, and thus, you know, how quickly they are to fall to the ground and thus leave the air. You know, I think that there remains a significant amount of investigation around this, but I would argue that the vast majority of infections still happen from mildly, but still symptomatic people that are within a certain amount of distance from each other. Normally we use a sort of a 1 meter or 1.5 meter, 6 feet guideline. But that is sort of the vast majority of infections are happening in that way, and that there's a fair amount of droplet transmission and or sort of contact within within that distance. I think, you know, the conversation around aerosol transmission is so important because, again, that there is no absolute cutoff that, you know, the droplets are absolutely going to fall within, you know, 6 feet or 1.5 meter. And clearly, you know, we've seen these super spreading events in the context of choirs. And so some of it is related to the amount of airflow that is around and the sort of the air exchange that is naturally happening in any one setting. It's also related to likely how viremic somebody is. And I think that would be indicative of how much virus would be inside any of those droplets. And thus how much virus is sort of being deposited out. And then clearly, you know, at the extremes, when somebody's singing or yelling and there's just a lot of exhalation, there's a lot more risk for, you know, people exhaling, you know, more significant amounts of virus. And so I think, you know, the idea of aerosol transmission in our minds, sometimes it makes us think about things like measles, which are really airborne and really can fly and fly pretty reasonable distances. You know, I believe that aerosol transmission is really, you know, it can exist, but I don't think that it is a major source of transmission. And I think that it's really still at the extremes. But I similarly like to say that it doesn't exist, I think is also disingenuous. Like clearly within certain settings, depending on a variety of different determinants, you know, people can be further than 6 feet, you know, 8 feet apart from each other, and there still be the risk of transmission. I think contact transmission and the idea of like surface transmission is something that's often discussed. And I think initially there was a fair amount of, you know, attention towards contact transmission, both indoors and outdoors, and I'll talk about those separately. I think over time, it's been decided that this is still more traditional in the context of droplets and like I said, sort of like low distance aerosols. The idea of contact transmission is, basically that when somebody is viremic and they have some form of like a mucosal discharge or they touch a mucosal surface, and that they deposit virus on their hands, that they then touch something, and it's a lipid envelope virus, so it doesn't immediately die when exposed to oxygen. It can survive, but in the context of like protected by that discharge. And so it kind of needs to be in a bit of a wet environment, moist environment. The virus on its own, if that liquid evaporates, that virus on its own is not going to do very well. And there might be like individual viral particles that can survive for longer periods of time, but in significant numbers, that virus is really at risk of dying. And I think we have to also just consider that, when we study things like that, viral particles can survive. There was a study, for example, out of Australia showing that viral particles could survive in a good environment on paper money for up to 28 days. But I think we have to tease apart the idea of a single viral particle and something that could actually infect you. And by that, I mean that this is now something that, if you touch it, it has to get on your hand. You then have to touch a mucosal surface. It has to go, enter the mucosal surface, go through multiple layers of squamous cells and then enter the blood and then find a cell that it would actually infect. And then infect that cell, and so all of those things, like at each one of those steps, you really need more virus for there to be a higher chance that there's going to be a successful infection event. And so I think even in the context of indoor transmission, I think these are folks that are normally within like households. I think there's a fair amount, or like congregate living settings where it's an indoor setting, the environment is good for it. People might be very sick, so there might be a lot of virus deposited, and they're high touch surfaces. So these are like banisters going up and down stairs. These might be bathroom handles or door handles, etc. And I think the interventions for those are to really clean with normal solutions, actually. Like this virus isn't special. It doesn't require special cleaners, doesn't require special laundry for that matter. But to really, clean those high touch surfaces, and to also keep in mind that, with certain cleaners, if you just like spray it and remove it, you haven't given it the contact time that it needs. So you can look at the different cleaners, but often a contact time of between 10 to 20 seconds before you wipe it off to really give that cleaner the time it needs to disinfect or kill the virus. I'd say outdoors, in general, I think we can take solace in the fact that there's been way less. And some people use the number 20 times, some people use the 200 times less. I think it's kind of unknown, but I do think we have a really good understanding that there's way less transmission that happens outdoors. And I think that's for a number of reasons. One, obviously there's a lot more airflow. There's likely some element in terms of, ultraviolet light from the sun in terms of killing the virus. There's some in terms of it just not being a great environment in terms of humidity, et cetera, for the virus to survive. And so I think, we've not seen, for example, transmission related to playgrounds or other settings where there's lots of kids or lots of folks. And I think that's important. And so I think that in those settings, contact transmission in outdoor settings likely is, I would venture to say it's as low risk as one is going to get these days. I think, obviously, again, risk is a continuum, and there's probably no such thing as zero risk, but it's incredibly, incredibly low risk for outdoor mediated contact transmission. And I would say even for aerosol transmission outdoors, I think one can use those sort of safe guidelines, because I think there you've just got so much more airflow, so many more dynamics, that some of those early studies that we saw that looked at airflow and people biking 10 or 20 meters apart, I think we just can take solace in the fact that there's been over 60,000 articles focused on COVID. And we've not seen, these sort of sporadic like playground or people who are in a biking group out biking together, all getting infected, etc. So I think that's really important. I'll say that, the question then relates to masking outdoors. I think, there have increasingly been, mask mandates put in place that have you wearing a mask anywhere outdoors. I think in general, as noted, like the risk for transmission is way less outdoors than it is indoors. But in the context of crowded environments and where there's a lot of people, the risk would then exist because you're basically removing the ventilation and the airflow that you would have in other settings where there's just more air around you to protect and to kind of move virus around and thus move it away from what you would be inhaling. I think that the idea of mask mandates when you're just out on your own, not near other people, I would worry about a little bit, because I think we do want people to still be able to enjoy themselves and rest and recharge so that they can really engage in like really wearing their mask indoors when they're around lots of other people and where the risks of transmission are high. And so often we've heard arguments, for example, that it might be easier to enforce if you have it universally, but I think from a public health perspective, I would worry that you're using up people's energy in a way that doesn't actually prevent a lot of infections. Last thing I'll talk about is this concern about groceries and, again, bringing things into your house. And so, we have seen outbreaks on farms where people are working. We have seen outbreaks in meat packing plants, etc. We have not noted any outbreaks related to like groceries. And so we know that there have been, even during the time of COVID, there have been like listeria outbreaks, there's been salmonella outbreaks related to groceries and produce, E. coli, etc. We have not seen an outbreak of COVID where the sort of common element within that outbreak was, having bought lettuce or strawberries or raspberries, for example. And so while I worry about the workers in those farms and providing them safe working environments, also just again related to airflow and all the things that we should be doing for them, I don't think that we've really seen any risks for consumers of those goods in their homes. And so I think people have now increasingly moved away from letting groceries sit there for 2 days, letting wiping down all groceries, etc. So I think generally we've moved away from that. And again, I don't, we haven't really noted any outbreaks. And I think just given the fact that, the way that these are handled and the way that they sort of move through, like there's just so much natural opportunity for the virus and to evaporate and to be killed via natural means, that there's no real need to use like other chemicals to wash those down. And again, I think the idea is you still want to have a lot of precautions, but you kind of want to use your energy for the really high yield ones. I do think, that most transmission events are still happening within working and living conditions. And so, so I'll just say that within homes, every time you leave the house, especially if you live in a multi-generational household and you don't have one room per person per household, that you really try and take whatever precautions you can as you enter the house to try to rid yourself of any virus that you might have on you. And so there's like simple things that you can do that are kind of low yield, like, or I should say like not a high bar. And so, for example, like really every time you enter the home, wash your hands. Really every time you home, even when I go out and do clinic, I actually enter downstairs and I change clothes. And then when I come up, especially coming from clinic. And so I think that there are things that we can be doing. We don't have to do special laundry. We don't even have to isolate our laundry. This virus, in normal warm temperature and with normal soap, would take care of any of the virus. But I think those are some of the things that we can really do within our households to really try and prevent, and also potentially consider high exposure, like if you are concerned and you are especially symptomatic and you don't have anywhere to isolate, really try and clean surfaces more often and to try to do whatever you can to prevent transmission within the household. In the workplace, I think the same thing applies. I mean, obviously, if one is feeling symptomatic, we want to try to create whatever means we can for those folks to not go to their work environment. And so obviously education, but things like paid leave, other means of support to ensure that folks aren't basically bringing virus into the building. Because what I'll say is within our long-term care facilities and our shelters and our other settings, once virus is in the building, then we're relying on infection prevention and control like IPAC and testing and all those things, but we're really relying on hope. And I think the best thing that we can do in all of these settings is to try to prevent virus from ever entering. So thank you.